All of you open this page. All of you open this page. Preparations of aldehydes from acryl chloride. From acryl chloride or acid chloride. Remember as acid chloride, right? Yesterday class I told you how to write acid chloride. How do you write acid chloride beta? Anybody? How do you write acid chloride? Yes. How do you write acid chloride? This. Yes, beta. How do you write acid chloride beta? Yesterday we discussed this one beta.
RC double bond OX.
RC double bond OH. We are replacing with what? Halogen. So everyone knows carboxylic acid, correct? Everyone knows carboxylic acid. In that, when you replace OH with halogen like chlorine, that is called acid chloride, isn't it? This is called acid chloride. Acid chloride. Correct or not? Very simple or not? Right? In carboxylic acid, replace OH with what? Halogen like chlorine, that is called what? Acid chloride. Now, in the preparation of this method, I am preparing only, remember one more thing, we are preparing only aldehydes. Only aldehydes. That means you may get a question here. Following which methods can prepare only aldehydes? Rosenmund reaction. Rosenmund reaction can prepare only what? Aldehydes. You got a question now here. Isn't it? You prepared one question here. Rosenmund reaction prepares only aldehydes only. Aldehydes only. Understood? Rosenmund reaction is a Nemer reaction. Very, 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 very important reaction. It prepares only aldehyde. Do you get ketones in Rosenmund reaction, beta?
No, sir.
No, sir.
No, you don't get any ketone in Rosenmund reaction. Now, next thing is what is a reagent? Okay, hydrogen in presence of palladium barium sulfate. Palladium barium sulfate. Also, it can be called Lindlar's reagent also. Lindlar's reagent also. Hydrogen, palladium, barium sulfate is a reagent for us. So, what is a reactant? Acid chlorides. What is a reactant? Acid chloride. This is the reactant beta. Acid chlorides are reactant, isn't it? Reagent is hydrogen in presence of palladium barium sulfate. Palladium is a catalyst here, beta, isn't it? Support this barium sulfate to the catalyst here. Definitely the product will be aldehydes. Okay. What is Rosenmund reaction? When acid chlorides reacts with hydrogen in presence of palladium barium sulfate, you are going to get only aldehydes. This is called what? Rosenmund reaction, isn't it? This is called what actually? Rosenmund reaction. Only 30 students are there, with including me, 28. 12 members are absent. Very important class today. Absent. Now we'll make some examples, beta. I will make some examples here. We'll see something here in a slideshow. From acid chlorides, we are getting aldehydes by using Rosenmund reduction reaction. I have taken benzyl chloride. In the textbook also they taken benzyl chloride. Hydrogenation, the catalyst, you are taking here what? Palladium and barium sulfate. You are going to get what actually? Benzyl. Now what is happening, beta? Very simple to remember. Chlorine replacing with hydrogen. That is only we are writing. Chlorine is replacing with hydrogen. Where we got hydrogen, beta? From here we got hydrogen. From here we got hydrogen. Understood here? Very simple reaction. This is no need for you. This is extra information. Will be useful in the NET. So in NCERT, no need for this one. Leave it that topic. So you are preparing what actually, isn't it? This method. Now let me see one more thing actually. I want CS3 I am taking this one, CH3 C double bond O Cl. Reacting with hydrogen, palladium, barium sulfate. Now tell me what is the name of the product? What is the name of the product here? What is the name of the product?
Methanol.
Methanol or ethanol. Tell me better, methanol or ethanol?
Ethanol.
Ethanol, isn't it? Because you have two carbons are there here. Okay. So again, how to make the product? You see, you have to replace this one with hydrogen. Correct. Now take CH3 C double bond O hydrogen. Completed. This is called what? Acetaldehyde. Acetaldehyde. Common name. IUPAC name. Two carbons are there. Between carbon single bond is there. Eth. Two carbons A in single bond. And this is for aldehyde functional group. Write down all. Ethanol. Many number of times we discuss this IUPAC nomenclature. Now here also what happens? Cl is replacing with what? Hydrogen. Same reagent we are taking here. Isn't it? What we get here? C double bond O H. What is the name of this one?
Benzaldehyde.
Benzaldehyde.
Benzaldehyde. Benzaldehyde. Also can be called benzene carbaldehyde. Also can be called benzene carbaldehyde. In your notebook, write down this reaction now itself. Put a heading called what? Rosenmund reaction. Write down the reactant, write down the reagent, and write down the product, and where change is occurring, that you have to write here. Important thing is that what is the change you are occurring here. This is the change you are occurring. This you need to write like this. Cl. You round up like this. You round up like this. Now, if you make like this, what happen? Organic chemistry is very, very simple. Neighbor reactions are very, very simple. If anybody say what happened, organic chemistry is very hard, means they are not listening to the class. They are not practicing the whatever they explain the reactions. If you practice like this, what happen? Replace Cl with hydrogen. It will be very, very simple reaction. What is the name here? Rosenmund reaction. Completed. Now, if you practice 3 or 4 times, it will be easy for you. Okay. Next, we will move to what? Next reaction. Okay. We'll move to what now? Stephen reaction. Next reaction will be Stephen reaction. This is also very, very important beta, Stephen reaction. And here, what reactant we are taking? We are taking nitriles. We are taking. What we are taking here? Nitriles are converting into only aldehydes. Okay. Nitriles are converting into what here? Aldehydes. In the previous case, Rosenmund reaction, acid chlorides are converted into aldehydes. Now, nitriles are converting into aldehydes. How? Let me see. So, actually, I will write mechanism later. First of all, I will write direct reaction. So that what happened will be easy for you. Okay. In examination, you can't write direct reaction, but at least it will be easy for you. Direct reaction. How? Let me see. In this case, RCN, alkyl cyanide. Cyanides are generally called as nitrile beta. They call you nitrile means nothing but cyanide, isn't it? Cyanide it is. Now, here the reagent is I am taking stannous chloride, SnCl2 reagent in presence of HCl, followed by hydrolysis reaction, H2O in presence of H plus. That can be written as H3O plus also. So this is the reagent. And this is the second reagent we are doing. That means second step it is. First means is the first step, second means second step. Now, if you take both steps at a time, we are going to get aldehyde like this. Now, why I am writing? Because to make you easy here. Now, cyanide converting into what here? Aldehydes. Isn't it? Cyanide, in the previous case, chlorine converted into aldehyde. In this case, the cyanide, CN, is converting into what here? Aldehyde. Very simple or not? You observe here, cyanide is replacing with what here? Aldehyde. Okay. Now, if you read these two reactions in one side, what happened? In both the case, the product is same. What is different? Only the reactant and reagent is different. Understood here? Now we'll move to what here? Actual mechanism. Generally, mechanism nobody asks in examination. You can write directly like this, but you have to put the second step also here. You have to put the second step. Don't put what happened HCl and write on the aldehyde. You have to go for second step also, then only we get the product. That is important. We can write like this also. Stephen reaction, no problem. You will get same marks. Now let me see the mechanism, what happens in RCN. Okay, when you treat this one with what? Stannous chloride, SnCl2 in presence of HCl, if you do what happens. Now what happens here actually? Now already you know one thing here. Cn means carbon, nitrogen will have triple bond. Correct or not? C triple bond N. In cyanide is nothing but C triple bond N. Now what we have to do here? Now this HCl in the presence of stannous chloride provide hydrogens to you. Provide you what? Hydrogens to you. Here one hydrogen and here one hydrogen. Now break the bond. Break the bond. Now what we get beta amper? R CH double bond. Correct? Finished? Very simple or not? Break one pi bond, put here one hydrogen and put here one hydrogen. And this is called what? Actually imines we can call this. The name of this one is called imine. First it will produce imine. Then after that if you do the hydrolysis reaction, H2O or H2O, H3O plus actually. H2O in presence of H plus or H. That means hydrolysis, we are adding some water in presence of acid. Hydrolysis reaction. You are getting this product. Correct or not? So you got two reactions, Nemer reactions here. One is Rosenmund, second is Stephen reactions. Both are completed here. Any doubts in these two Nemer reactions, beta? Any doubts you're having?
So what about these esters?
हाँ एस्टर्स भी बताऊंगा नेक्स्ट इस पे आएगा वो नहीं मैं अभी तक शुरू नहीं किया ना इसमें आएगा you will get definitely isn't it once we complete the Stephen reaction. This is not Stephen reaction beta, that is the reason I am not explaining here. These are not Stephen reactions. Stephen reaction is only up to here only. Understood? Don't write these reactions in the Stephen reaction here. Stephen reaction means the reagent what we have take beta, this will be the reagent beta. This is the reagent for what? Stephen reaction. Right? Any doubts here? Up to here? Up to here, if you have any doubts, you can ask me now. This is also you can easily remember. How? You see here, just break here what happened? Break here and put water here, isn't it? One oxygen here, two hydrogen. Now this will convert as ammonia, will be removed, and this will be aldehyde. In this way also you can remember. But don't make too many mechanisms. If you get too many mechanisms, what happened will be very difficult to remember. Remembering is very simple. No? Cyanide converting into CHO is very simple. No? Correct or not? Correct? Any doubts you are having? Stephen reaction? No. Now let me see now remaining reactions in which same type of products we are going to get. That is not Stephen reaction, but you are getting same type of products with same reactant. You are getting same products, isn't it? Same reactant. They are getting same product here, but different reagent. They are called what? DIBAL. This is called what actually? DIBAL. DIBAL is nothing but what? D for what? This is D. Di. I for what? Iso. D for what? Di. I for what? Iso. B for what? Butyl. B for what? Butyl. And A for what? Aluminium. Al for what? Aluminium. Al for what? Aluminium. Okay. And hydrogen, DIBAL-H. Hydrogen for. This is the hydrogen. Now isobutyl, it looks like this. It looks like this actually. I'm writing here. Let me write. You have to make notes बेटा यहाँ पर. देखना नहीं है, फिल्म नहीं है, ऐसा देखना के लिए. तो आपको पेन लेकर पेन पेपर में लिखना है कंपलसरी. टेक्स्ट बुक में लिखो, नहीं तो टेक्स्ट बुक में राउंड अप करो ऐसा. आपका पास टेक्स्ट बुक में रहते हैं ना. I know most of them they don't have textbook also. Who are they also? I know that one. The names also I know. Who are not having the textbook, I know the names also. See, what I'm saying is something at DIBAL structure. Aluminium, write down and put one hydrogen here. Okay, remaining what I'm writing here. Isobutyl I have to write here. This is called isobutyl. Take one more time. This is called what? Isobutyl. Isobutyl is also what? Isobutyl. How many times they can isobutyl? 2 times. Therefore, diisobutyl. Okay, diisobutyl. Next, what happened? Aluminium. Next, what happened? Hydrate. So DIBAL-H. Simply they call DIBAL-H, or we can represent aluminium H isobutyl. I'm writing this part. I'm writing I for isobutyl, Bu, IBU. Okay, IBU means nothing but isobutyl. Understood here? So when you take DIBAL, same Stephen reaction is taking place. Okay, you have remember like this. Okay, when you take DIBAL, what reaction is taking place here? Stephen reaction is taking place here, isn't it? Stephen reaction is taking place when you take what? DIBAL. In this way, you remember. Don't practice for this. No need to practice the reactions here. What you have to remember like this: when you take DIBAL, Stephen reaction will take place. Okay. And now in this case, one more thing: if you have any double bonds here, they do not disturb you. They retain in the product. So don't disturb the double bond when you are writing the product here. They retain in the product side. Next, what happened? Esters are also can be converted into aldehydes by using what happened? DIBAL-H. In this case, Stephen reaction, what happened? That means Stephen reaction reactant is different. Okay, Stephen reaction reactant is different. Stephen reaction reactant will be what actually? Cyanates. Reagent will be standard chloride. That is okay. But I want to say what even reagent is different, even reactant also different. Okay, so when you convert esters into aldehydes, what you have to take? DIBAL-H. Again, you have to take same reagent. Understood here? So here, what we discussed now, one is Rosenmund reaction, in which what happens beta? Acid chlorides will convert into what actually? Aldehydes. Next, Stephen reaction. Cyanides are converting into what? Aldehydes. Next, DIBAL we have taken. DIBAL also converts cyanides into aldehyde and also convert esters into what? Aldehydes. So what is the function of DIBAL-H beta? Because it will come in conversions here. What is the function of DIBAL beta? Conversion of cyanides into aldehydes. Conversion of what happened? Esters into what here? Aldehydes. In this way, if you remember what happened, it will be easy. Now, what happening you observe here? Ester group, C double bond O, OC2H5 is called ester group. This is called ester group. Now, this is converting into what here? Aldehyde. Okay, very simple to remember. Practice in this way is easy for you. Write down in the notebook like this after the class or now itself, whatever it may be, you write compulsory in the notebook. Understood? Any doubts you're having? Any doubts you're having?
Sir,
बोलो बेटा. बोलो बेटा. Now you observe here what happens. Cyanide convert into aldehyde. Intermediate product is what? Imine. You got the imine. ये सारी चीज आपको लिखने की जरूरत नहीं है, ठीक है ना? For example, you taken methane nitrate or hydrogen cyanide. What we got here? In the place of cyanide, what we got is aldehyde. Right? When you take DIBAL, again cyanides are converted into what here? Aldehydes here, right? Here also what happens? Cyanides are converting into aldehydes. Okay. Take ester group, what happened? They also convert into what here? Main product is important for us. This is no need for us. Nobody asks you in examination about this one. You need what? Main product for us. Okay. Like this. Ester group convert into what here? Aldehyde. Right? कल मैंने कंप्लीट किया इसको. Ethylene gives, yesterday मैंने complete किया इसको. Ethylene will convert into what? On ozonolysis. Breaking this one. What we get here? Formaldehyde.
Formaldehyde.
How many moles? 2 moles.
2 moles.
Right. Yesterday only we discussed this one. In this case, in Rosenmund reaction, what happens? Sulfur can act as, actually sulfur is not given textbook, but sulfur also can be taken is there, which is a poisonous to the catalyst actually. So in NEET examination they may ask, but even NEET also they don't ask because they 60 follow what happened the syllabus, NCERT syllabus. So you don't need this one. Even maybe you may get in mains examinations. Now let me see what happened. Next one. It's third type of. So everyone, 3 methods we have completed. One is Rosenmund, second is Stephen, third is what? DIBAL. Correct? Now let me see the next one. Again aldehydes only, preparation of aldehydes only by using what? Hydrocarbons here. Let's see the hydrocarbons now here. In next month you may have pre-board examinations. Okay? You may have, because in Hyderabad region, next month they are starting the pre-board examination by December 7th. So you may have exam also maybe in next month. So all of you have to be prepared for that one. So for organic chemistry, what happens separately, no need read what happened. You have to daily practice whatever I am discussing, what happened, practice these questions actually. Remaining chopped subjects completed, syllabus completed.
No, sir.
Biology completed, no?
Only biology completed, sir.
Physics also there, I think. Right, okay. Let me see the this is also something important there actually. By oxidation of methyl benzene. By oxidation of methyl benzene. In this case, what will take? Chromyl. Remember this one better. ये सारी चीज आपको पढ़ने की जरूरत नहीं है. Simply you take what? Chromyl chloride. What is chromyl chloride? CrO2Cl2. It looks like this. CrO2 double bond O, Cl and Cl like this. Chromyl chloride is. Okay. 2 chlorines, 2 oxygens. Very important one beta, chromyl chloride. Okay. Now, it will convert the methyl group into what? Aldehyde group like this. Let me see this one in the reaction like this. Now, what is happening here? This is toluene. Everyone knows no? Methyl benzene, also called what? Toluene. Okay. Names are very, very important. Methyl benzene, toluene. Now, take chromyl chloride CrO2Cl2. Now, directly you can write the product like this here. 2 options will be there. One option like this here. You may, for average students, this is best method. Writing like this is the best one. For average students, what I am saying here. Takes, first step is what? CrO2Cl2. Second step is, most of the case, second case. In the previous also, second step is what beta? H3O plus only, no? Hydrolysis reaction. Second step is most of the case hydrolysis reaction. Now what you have to put here in the place of CS3 beta? RD. This is for average students beta.
CHO.
CHO. Why? Because they don't have much time, no, for practicing the mechanism, no. Average student, they don't have much time because they spend more time what happened for playing, what happened chit chatting, or otherwise what happened playing on in mobile phone. So because they don't have enough time. So that is the reason they can choose this step actually. Because they're very busy for what happened with phone, otherwise what happened in ground. So for them, what happened? Methyl can be converted into aldehyde. But what happens, in this one disadvantage is there. You can't remember all these reactions like this. You may get definitely what happened, some type of doubts here. Whether I have to take in Stephen reaction, whether I have to convert cyanide into chlorine into aldehyde or cyanide into aldehyde. Stephen reaction, Rosenmund reaction. Both may have confused ho jayega. So now, how to make in the mechanism concept? This is very simple. Better to write like this, isn't it? But if you want to write what mechanism, how to make this one? So in this case, what we have to do here, this chromyl chloride will definitely attack on the hydrogens. Now, wherever the hydrogens are there, put here, okay? Like this. I'm putting actually 3 hydrogens are there, but you can't remove all the 3 hydrogens. You can remove only 2 hydrogens. Now put here for each hydrogen, put one chromite chloride like this. O Cr, isn't it? Next what happened? OH. Next what happened? Chlorine. Next what happened? Chlorine like this. This is the thing actually. And how many types here? How many times? One more time here. CO. One more time also. Chromium, OH, isn't it? Cl. If you are unable to write like this, if you feel difficult for this one, you make like this actually. You may write like this also, no problem for you. Okay, put CH here. Now CrO2Cl2 है ना, लिखो यहाँ पर CrO2Cl2, you can write like this, no problem for you. But what you have to remember here, you have to write one more hydrogen here. CrO2H you have to write here. Put one H here, then no problem. Same thing only I am writing. See, two oxygens are there. Yes, two oxygens I have written. Two chlorines are there. I have written two chlorines. One hydrogen and oxygen you put here, no problem. Okay. In this way also you can write. If you know the structure, what happened, definitely you can make this. Otherwise, better to go for this method. Now, this reaction is called what? Etard reaction. Etard reaction. Name of reaction is Etard reaction. Now, what happening here? Toluene is converted into benzaldehyde. Toluene converted into what here? Benzaldehyde like this. The reagent what we have taken? Chromyl chloride in presence of H. This ko chhod do, CS2 chhod do, what one? Leave it that one. Because many reagents also will make you what? Doubtful for you. Unable to remember all these things. Simply remember chromyl chloride, CrO2Cl2 in presence of H plus. Now, second step is what? Hydrolysis reaction. Second step is at least you write hydrolysis. If you don't remember H3O plus, write down the hydrolysis reaction. It is again the toluene is converting into benzaldehyde only. Reagent is different. The reagent we are taking, that is different actually, isn't it? Whatever the reagent we are taking here, that is what? Different in this case actually, right? What is that reagent here? Chromic oxide and acetic anhydride. The reagent we are taking here, what happened? Chromic trioxide plus acetic anhydride. Acetic anhydride already yesterday I given the structure also. Acetic anhydride. Acetic anhydride for the acid derivatives here. This is the acetic anhydride. Okay. Now here also we can make same like this. Same. Put what happens CH here and put this group here. Whatever this group is there, no. Otherwise you put this group actually. 2 times here. Okay. This group CH3, C double bond O, oxygen on where? CH group. Taken how many times? 2 times on CH and put here what? Benzene like this. Put here benzene like this. Okay. In the previous case, what were taken? CrO2, HCl2. Now you take this bond, CH3, C double bond, where that is getting from? This bond. So both the case what happened? That means what you take? Etard reaction and in this one, both are what? Same reactant and same product. Okay, right. And third one, this second one in this case, this is very, very important. This one is very, very important. Side chain reaction is very, very important. We'll see this one. Especially they are asking this side chain chlorination in the conversions. Conversions they are asking. Now in this case also, the same thing is happening here. Toluene is converting into benzaldehyde. Correct? Now what happening here? Generally when you observe beta, I will explain 2 things here. When you take toluene, CH3, chlorine in presence of FeCl3, what is the product you are going to get? Anybody? What is the product you are going to get? Anybody? Please speak out.
Benzyl chloride.
Benzyl chloride. Because their benzyl chloride is there. That is the reason. Here, sunlight is there.
Hallucination, sir.
I have not taken the sunlight. Here, what is taking? Chlorination. Right? Halogenation. That means chlorination taking place. What is the product better now here? Orthochlorotoluene, parachlorotoluene. Correct or not? Orthochlorotoluene and parachlorotoluene we are getting here. Here also we are getting a chlorine. One is orthochlorotoluene, other is called parachlorotoluene. When you take what? Lewis acid, FeCl3 or AlCl3, a Lewis acid, if you take what happens? You will get what? Orthochlorotoluene, parachlorotoluene. But here what they given you? Sunlight, H2 is nothing but what? Sunlight is given. But when you take sunlight, the reaction takes place on sp3 carbon. This is sp3 carbon. The reaction takes place on sp3 carbon. But when you take Lewis acid, the reaction takes place on which carbon beta? sp2 carbon here. The reaction takes place on sp2 carbon. Understood here? What I am saying here, the difference. When you take sunlight, the reaction takes place on methyl, sp3 carbon here. But when you take Lewis acid, the reaction takes place at ortho position or para position, that is sp2 carbon. Right? Now, what I am writing here, when you take sunlight, hydrogens will replace with chlorine. Now, there are, I told you all the hydrogens may be replaceable, but I have taken stoichiometric calculation, I have taken 2 chlorines only. So, in that case, what happened? What we got here? You observe here. Is it visible for you? What I am writing is visible for you?
Yes, sir. Yes,
now,
sir.
I am replacing 2 hydrogens with 2. In the previous case also, we replaced 2 hydrogens only. No, here also. Yes, 2 hydrogens only we are replacing. Here also what happened? The 2 hydrogens we are replacing with chlorine here. Okay. After this, what is happening here? When you do what happened? Hydrolysis reaction, you again replace this chlorine with what? OH groups now. Replace this chlorines with what? OH groups. Like how many OH groups? Again 2 OH groups. Again, the 2 chlorines now will replace with what? 2 OH groups because of what? Water we are adding. Now what you have to do? If you have 2 or more OH groups on carbon, whenever if you have 2 or more OH groups on carbon that is highly unstable, immediately water we have to remove. Whenever if a carbon is having 2 or more OH groups, see this carbon is having how many OH groups here? 2 OH groups here. Therefore, it's highly unstable. Now, water is removing here. So, definitely what happened? You will get what happened like this here. So, you are going to get this product. C double bond O. C double bond OH. So, we got again benzaldehyde. Nothing but CH4. So, this is called what? Side chain reaction. It's a very important reaction, this one. Isn't it? Very important reaction, side chain reaction. They don't ask directly. They ask in conversions here. This is for you write textbook for conversions, write down like this. Any doubts you're having up to here? Anybody having doubts here? Up to here. Now let me see Gattermann coch reaction. Gattermann coch reaction. In this case, we are converting benzene directly into benzaldehyde. Now we are getting directly CH4 group. Now what are the reagents we are taking? Carbon monoxide, hydrogen chloride in presence of anhydrous aluminum chloride or cuprous chloride. So this is the thing. Carbon monoxide, hydrogen chloride, anhydrous aluminum chloride or cuprous chloride you can take. Then what happens? You will get the benzene. This is called Gattermann coch reaction. The name of the reaction is called Gattermann coch reaction. So when benzene is treated with carbon monoxide and HCl in presence of anhydrous aluminum chloride or copper chloride or cuprous chloride, the product we are going to get is called benzaldehyde. This is known as what? Gattermann coch reaction. So we have completed the preparations of only aldehydes. Okay. Now, if you prepare all these in one side like this, easy for you. Okay. Now we'll see now preparations of ketones. Now only few methods are there. So we finish this preparation of ketones today only. Now here also ketones can be formed by the acid chlorides. Acyl chloride is nothing but acid chlorides only, just like Rosenmund reaction. Okay, how Rosenmund reaction is converted into aldehyde. Similarly, ketones also convert acid chlorides into convert into aldehydes. Let me see this one. You observe this from here. If you observe, better to observe here. Better to observe. First you observe here. Next you will see this one also. Now acid chloride. Yes, it is acid chloride only. We have seen the Rosenmund reaction. Reacting with dialkyl cadmium. Reacting with what? Dialkyl cadmium. Now what we got here, in the place of this one, it is giving what? RH. So you got here ketone. Now we got here RH. Now here also what happened, you observe in this manner. If you observe what, better to write like this. Instead of writing everything, you write like this. In the previous case, what we got better? Chlorine replaced with hydrogen. Now it is replaced with alkyl group. For example, if I write like this, CH3, okay, CH2, C double bond O, Cl, right? Reacting with CH3 taken twice, cadmium. Now tell me what is the name of the product?
Pentanone.
What? Remaining one? Because class strength is 40. It looks like that means that is your class strength is only 2 or 3 only. It looks like me. How many are there?
Butanone.
40, including me, 40. Means 38 students are there now. 30, out of 38, what happened? 1 or 2 members are speaking. Remaining one, they are dumb. देखो यहाँ पर क्या है इसमें? R is coming in the place of chlorine. Now what is R here? Methyl group. But how many methyl groups are there here? 2 methyl. Now you take 2 moles here. Now here 1 mole of dimethyl cadmium will react with 2 moles of this acid chloride. Now we get what product here? CH3, CH2, C double bond O, CH3. Butanone we got here. Butanone we got. Butanone we got. Understood? We'll take one more here. Now let me see how many students are what happens sleeping now. I will get how many students are sleeping now. Easily I can know now. C double bond O, Cl. Reacting with diethyl cadmium. Diethyl cadmium. Diethyl cadmium. Now tell me what is the product?
Butanone.
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 Same you are getting. Same we are getting or different we are getting?
Same.
Same we are getting. Same. Again what happens here? This is the R group. Ethyl group will takes the position of the chlorine here. CH3, C double bond O, and we get here CH2, CH3. Both are what same. Here also we are going to get butanone only. So why I am expressing in this way? Because they may ask in conversions. Nobody asks you directly write the product here in conversions. Okay. When you see acid chlorides, when you see dialkyl cadmium, you see dialkyl cadmium react with acid chlorides to give what happened? Ketones. This is actual reaction. Okay. Now what is this reaction actually? This is no need for us. But in conversions what happened? How we get dialkyl cadmium? Generally dialkyl cadmium is not available in nature. So we have to prepare in that. So in that case what we have to take this reaction will be useful for. RNGX when react with what? Cadmium chloride. Now what happens here? Very simple. Here it will react 2 moles here. These 2 moles of alkyl group will come here and this chlorine will go here. So what we get? Dialkyl cadmium. You got this one. Okay. When you treat RNGX with cadmium chloride, the 2 alkyl groups will come here like this. The two alkyl groups will come here like this. So we got that reagent we are getting. For getting the reagent, we have taken this reaction. Right? Any doubts you are having in this one? Preparation of ketones from acid chloride or acyl chloride. Any doubts you are having, beta?
No, sir.
Yes, right. Next we'll take second from nitrate.
No, sir.
From nitrates also we can convert into ketones. Right? Just like what Stephen reaction, how we converted nitrates into aldehyde, ketones also can be converted nitrates into what actually ketones. Let me see that one. In Rosenmund reaction, we converted acid chloride into aldehyde, and here also we converted isn't acid chloride into aldehyde ketones, and here also like what happened, Stephen reaction, we are converting nitrates into ketones. In this way, if you practice what happened, it will be easy for you. You can remember for a long time. That means there is a relation is there. First two reactions are what? Rosenmund and Stephen for what aldehydes. Here also what happened? First two, just like what happened. Reactants are same. Not everything. Reactants are same actually. Now in this case, what happening you observe from the nitrates? Very simple here. I'm writing like this. Now here, what I'm writing here, this is a Grignard reagent. Everyone knows this one. This is a Grignard reagent. RMGX. RMGX. Here R place I have taken phenyl benzene. Magnesium X place I have taken bromine. I have taken Grignard reagent. Now what we have to do here? Now, simply you do one thing here. Break one pi bond. Only break only one pi bond actually. Now put this R group where here. And the remaining part is there. No, that remaining part you keep on the nitrogen. Correct? R you place on the carbon. Remaining part you place on the nitrogen. Right? Now what we get here? Generally what happened? Carbon positive character. Nitrogen negative character because of electronegativity. Magnesium what character? Beta positive character. R will be negative. So negative will always move to positive and positive always move to negative. Now what we are going to get? This we are going to get. CH3, CH2, C. This carbon is getting what actually beta? Phenyl group here. This nitrogen getting what? Magnesium group. After this, what we have to do? Now we are adding water, hydrolysis, here it is there. Hydrolysis reaction we are doing. Now how to make hydrolysis reaction? Break the bond. When you are doing the hydrolysis reaction of double bond, put directly double bond over here. Put what actually here? Directly double bond. You will get the product. Understood here? Okay. Put the break the double bond completely. Now give two hydrogens to this one and give what double bond to this one. You got the product actually. Nobody asked the byproduct. This will be the product here. Propiophenol. Correct? Understood? Now I will take another reactant like CH3, isn't it? CN reacting with CH3MgBr. CH3MgBr. And first this one. First one, CH3MgBr. Second one is what? Hydrolysis reaction. Now tell me the product name here, name of the product here.
Ethanol. Ethanol.
Ethanol.
Ethanol.
Ethanol. Beta, with two carbons, you can't write the ketone beta. It is impossible to write ketones with two carbons. The ketones will start from where? You have to write at least 3 carbons for writing the ketone. With 1 carbon, with 2 carbons, you can't write the ketone. So there will not be methanol. There will not be what? Ethanol. It's impossible. Follow the mechanism. I'm writing the mechanism. What is happening? You will see. So I'm writing the mechanism CH3, C triple bond N. Right? Now this is the R group beta. This part is R group. Will come where? On carbon side, and remaining part will come where? On nitrogen side. Now remove the 1 pi bond here. What we get here? CH3, C double bond N. This part will get what? CH3, right? This part will get MgBr. This part will get MgBr. Now, when you do hydrolysis reaction H3O plus, now break the double bond O, double bond, put what double bond O here? Put double bond O here. Now, what we get here? CH3, C double bond O, CH3. This is called what actually? Ketone or acetone. Acetone or propanone. Acetone or propanone. Understood here? We'll take one more example. We'll take one more example. CH3, CH2 cyanide reacting with CS3, CH2, MgCl. Followed by what happened? Hydrolysis reaction. Now tell me the product name better.
Pentanone.
Pentanone. Right. Now one more thing also I can make you. Numbering also we have to do, no? So you no need to write everything. Simply what I'm saying here, for writing the product here, you put this whatever the R group here, okay? Remove the nitrogen here. I'm writing some shortcut. It is not a mechanism. I'm writing shortcut. Okay? How to make the product. Now put the R group here in the place of nitrogen. Right? What we get here? CH3. This will be easy for you. CH2, C, CH2. Write down in this manner. Don't write what happened like this. Don't write CH3, CH2. Because many of the students write like this also. Because this is the first point, no, right? They will directly connect this one here. Connect what point here? CH2 part. Because this is joining with magnesium. So you have to break here actually, not here. So you have to connect whichever is joining with what? Magnesium. This part you have to connect actually. So what we get beta amper? CH2, CH. Now put double bond over here. You got the product. This is shortcut only. But too many shortcuts also make you what? Unremember. You may get forget easily. That one is also, but mechanism is very simple actually. So you will get actually 3 pentanone. You will get here what? 3 pentanone. Understood here? How to write here? Simple thing. RCN, okay, RCN reacting with RMgX. How to make the product here? Remove the nitrogen, RC, replace with R group here. From here, this side you have to replace, not from this side here. Okay, from this side you have to replace. R, put here double bond. Oh, you got here the product. You practice in this way, it will be easy for you. Correct? Next. Next, we will see the last one. This is the last reaction. We'll see now. Now, in this case, this is already we discussed many number of times in the 11th class. Electrophilic substitution reaction, Friedel-Crafts acylation. In the 11th class, we have discussed here. The same thing, isn't it? Now, this C double bond O R group will replace here. Will get like this. Okay. You have seen many number of times like this. If you go for 11th class electrophilic substitution reactions, you will get this reaction. Now let me see the reaction. I am writing one example for this one. We'll take one example here. I have taken benzene here. Okay. Now reacting with CS3 C double bond O Cl. And this is what AlCl3 or FeCl3 we can take. AlCl3 or FeCl3, which are nothing but Lewis acids. Which are nothing but what? Lewis acid. Now this part from here you have to connect. You break this part here. From this part you have to connect here. You are going to get a famous product. The name of the famous product, anybody? C double bond O CS3. What's the name of the product here? What is the name of this product? Yes. What is the name of that product? Yes, better. What is the name of that product?
Acetophenone.
Very good. What about remaining? They don't have the mouth, otherwise they anything they put in their mouth. So here, this part will connect here. C double bond O. Like this. This is the name of this product will be name of this one. This is acetophenone. Everyone should know this one. Acetophenone is very, very important. This one will be what? Benzophenone. So acetophenone, benzophenones are very, very important products here. So this is about what? Preparation of only aldehydes and only ketones here. Understood? Now, this is the exercise for you. 12.1 and 12.2. We have already done today only. Cr2O2Cl2. Here no disturbance, no reaction takes place here. Now this will convert into what beta? CH2. Yesterday we discussed this product. What we got in yesterday, if you observe here, CS3, C double bond O, CS3. Yesterday we have done this one. I want entire the reaction. Don't write the product only. Write down entire the reaction with mechanism. Just now we completed this one. What we get here? CS3, C double bond O. This is R group here. Now R will join here. Correct or not? R will join from here. CH2. No, don't join from here. No, don't join from here. What is happening? C6H5. You got the product here. This one just now we done this one. Attacks here. Acylation. Abhi namne kiya. Last reaction only. Benzene getting this group. C double bond O. What we are getting? C2H5. Acylation. Just now abhi complete kiya yahan par. Acylation. Yahi hai na? Abhi complete kiya humne. Acylation reaction. This one is only no. So all are what? Very simple. If you know this methods, okay, write down. This is you take as example as a homework. Complete that one. Tomorrow we'll see the physical properties and we'll start chemical properties also. Right? Anybody having doubts now? Is anybody having doubts? All of you completed the IUPAC nomenclature?
No, sir.
Complete this one. By Monday, you need to complete this everything, carbonyl compounds. On Saturday, I told you, write down the Nemer reactions. Here also, whatever the Nemer reactions you are getting in today also, write down in that one. By Saturday, whatever the Nemer reactions we completed, you have to submit by Saturday. Today's also. Today, what we discussed, Stephen reaction, Etard reaction, Rosenmund reaction, the Gattermann coch reaction, all these we have to compulsory, you complete by Saturday only. These are IUPAC nomenclatures. Write down these IUPAC nomenclatures when you get time now. Right? Remaining questions we'll discuss tomorrow. Now, tomorrow we'll take the class at 10:30. Tomorrow the timing is 10. Regular timing will 10:30 to what? 11:45. Now, what about that CCT7?